Good evening, and welcome to what is the 5th annual Prism Awards for Photonics Innovation. We have a room full of very bright people, a lot of big ideas, CEOs and product teams, business starters and investors, competitors, people from all over the globe, businesses large and small. The thing that brings us together is we all honor innovation and new products, and we look forward to hearing about several of the most outstanding new products of 2012. The next category is Test, Measurement, and Metrology. To present this award is a gentleman who has spent the last 30 years in Silicon Valley working in R&D management positions as well as executive roles in Avago, Agilent, and HP Labs. Currently, he is nurturing a culture of innovation among scientists who are improving communications, solar energy, displays, and other cutting-edge research. His group is a vital new part of Corning, a company with $7 billion in sales and nearly 29,000 employees worldwide. Please welcome Division VP and Director of Corning West Technology Center, Wagi Ishak.
It's a pleasure to be here, and like Yan, I'm also an immigrant who came from Egypt and left to North America in 1973, and my story is very short. It was one day when I took a 18-hour flight to Toronto. It was very late, and I was really tired, and it's the first time that I land in a country where everything is in English around me, and I just went to a restaurant at the airport, and I asked the guy, I said, "Where is the bathroom here?" So he looked and said, "Read." And I said, "I can't read." He said, "Look at this sign." And I saw the sign that says, "For bathrooms, use the elevator." And I did the translation. Well, I said, what kind of culture is this? I want to go home. So again, it is really a pleasure to be here, and I worked for Hewlett-Packard, Agilent, and Avago Technologies for 30 years. Most of them are in photonics, and optoelectronics. I had the pleasure and the honor to lead teams that worked on building more than 40 test and measurements, all photonics, optical spectrum analyzers, optical network analyzers, optical sweepers, wavelength measurements, and polarization measurements. We also developed and invented the optical mouse that many of you are using now. And now I'm with Corning, a true $8 billion, not $7, $8 billion company that is built on optical sciences. So we are the largest company in making large sheets of glass. Imagine a 3 meter by 3 meter by 0.3 millimeter thick. So it comes down from the robot, it's just like a piece of paper coming, and that's with a very, very high quality optical properties that's used in many displays. We're also the largest optical fiber company in the world. We make hundreds of millions of kilometers of those fibers, so many of you are using those, propagating your bits on those optical fibers. So it's great to work with a company that really appreciates R&D. One of the very few companies left in the US with commitment to central R&D. The US National Academies just published a report entitled Optics and Photonics, Essential Technologies for Our Nation. I recommend that you go on the website for the National Academies and download the PDF file. I was a member of the 16-member committee that wrote the report. We talked about the amazing impact of photonics on the world economy, and we also talked about 5 big grand challenges. I will mention them in a minute here, but I'm offering those to the innovators here in this room to think about them and try to solve those grand challenges. But truly, optics and photonics have changed our lives, as many of the presenters talked about. It's in every display, in the smartphone, your TV, your computer monitor, and optical fibers, in sophisticated medical diagnostic tools, It's also in solar panels and LED lightings. In other words, it's truly a $100 billion, very fragmented industry. And it's always in the background, as people mentioned. But that's okay. I think it's serving humanity and serving the human race, so it's really good to be in this industry. Some of the numbers that I always hear and really mind-boggling is, right now we're using 2 trillion giga or 2 trillion billion bytes of information on a yearly basis around the world. I used to call it the Tera era in 2000. Now it's the Zeta society. The next thing is Iota, which is 10 to the 24, and nothing after that. We don't have any Latin or any Greek number for beyond maybe the Googleplex, it's 100 to the 10 to the 100. Expectations are also that we will be using 21 billion connected devices in 2015, so 3 per person on this planet. So I think this is very amazing and very exciting. Quickly, I'll mention the grand challenges in photonics that we came up with. How can the US optics and photonics community invent technologies for the next factor of 100 cost-effective communications propagation? People have the appetite for bandwidths. So this is a major grand challenge. How can the US optics and photonics community develop a seamless integration of photonics and electronics and have the system thinking? Like you mentioned, George, is it very important? Because we are technology-driven in photonics. Build a laser and find an application for it in the future. We ought to stop that. How can the US military develop the required optical technology to support platforms capable of wide area surveillance and image processing? Number 4, how can the US energy stakeholders achieve cost parity across the nation's electric grid for solar powers in 2020? How can we have to reach that level before solar power really become pervasive? And number 5, how can the US optics and photonics community develop optical sources and imaging tools for very high resolutions, especially in manufacturing? Those are major grand challenges. Now to the category. Essential to all those devices and systems is test and measurements and metrology. If you think about the test and measurement engineers, they are even more in the background. It's not very glamorous to be in test and measurements. I was in that for 25 years, and you're not in the forefront. It's always in the background. But it's very, very important. It accelerates the development of the next device. So I'm really glad to see SPIE bringing those innovators to the foreground and honoring them for their innovations and creativity in this field. So let's look at the categories and the finalists.
Design is a funny word. Some people think design means how it looks, but of course, if you dig deeper, it's really how it works. The finalists: KM Labs, Chromatis; Linden Photonics, Lindex Optics Cleaners; Resolution Spectra Systems, Zoom Spectra;
And the lucky winner in test measurements and metrology is Linden Photonics with Lindex Optics Cleaners.
All right. I want to thank everybody that voted for Linden. We won back in 2010, and I didn't have a speech prepared, so I made sure I'd have one this time, because I sounded like an idiot back then. So, and if I sound like an idiot now, it's because of the open bar, so I apologize. I want to thank everybody who voted for Lindex and recognizing the breakthrough technology that we've been toiling over for more than 3 years now. And I want to special thanks to Dave Geldart, our engineer, who's been working at Linden Photonics, tirelessly adjusting formulas and cleaning connectors and helping us fine-tune this nanomaterial. We've been fortunate enough at Linden to develop some generous funding through the Department of Defense, the SBIR program, to develop this technology over the last 3 years, and I really think we've come up with something remarkable. This cleaning product harnesses the power of nature to provide a cleaning material that uses the same principles as a gecko's foot, actually. It's pretty neat stuff. It's something that's orders of magnitude more effective than any other products in the photonics market for cleaning, and it's gratifying to see other people recognize that, so we thank you. Being a small business, and we are a very small business, sometimes we sit at our desks and we stand in the lab and we want to be part of something bigger. And, being up here, being part of this, getting a chance to mingle with all these amazing professionals and the other nominees for this award, gives us that opportunity to be part of something bigger. So, again, we thank you. I'd like to give a shameless plea to the industry to not let this technology die on the vine. Lindex, like many other technologies developed under SBIR, can enter the dreaded valley of death after phase 2 funding ends. This is when the small business has gone through all the development, but doesn't have the resources to sell and market the product commercially. So, we're looking for partners to distribute this product commercially, service the fiber optics industry. And if you have any interest, come talk to me after. I appreciate it. Thank you very much. I want to give a shout out to Mark and to Anna as well. Thank you.